Hi students, in the previous video we discussed the concept of hashing. Generally in the hashing we will use a hash table and what is the hash function used. These things we discussed in the previous video, and also we discussed what is meant by a collision. Now in this video what we are going to discuss. So we want to discuss collision resolution techniques. That means how to resolve collisions if we get the collisions. Collision resolution techniques. Okay. What is meant by collision? First of all, what is meant by collision? Collision means two or more keys mapping to the same bucket. Mapping to the same bucket is called collision. That means, suppose this is the hash table 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. For example, this is the hash table. For example, this is the hash table. Now I want to insert like 10, 20, 30 with the hash table size 10. So how can we insert? So the general hash function used is 10 modulus 10, which is equal to 0. So 10 is inserted here. Similarly, 20 modulus 10 equal to 0. So collision occurred. So 10 and 20 are mapped to the same bucket. So collision occurred. Then how to resolve these collisions? These collisions are resolved by using collision resolution techniques. Collision resolution techniques. Now, what are collision resolution techniques? So, collision resolution techniques are mainly divided into four categories. So, what are they? First one is separate chaining. Second one is open addressing. Third one is rehashing. Fourth one is extendable hashing. So now, what are these techniques? Separate chaining. In separate chaining, the data structure used is linked list. So the elements are stored in the form of chain. That's why it is called as a separate chaining. The hash function used is h of key equal to key modulus hash table size. Okay. Now, second one is open addressing. So this open addressing is divided into three techniques. One is linear probing. Second one is quadratic probing. Third one is double hashing. Now, linear probing, here I will write summarizedly the hash functions used. Okay, so linear probing, the hash function used is capital H of key equal to small h of key. So suppose this is, assume small h of key. Small h of key plus I modulus hash table size, where I equal to 1, 2, 3, 4 and so on. So capital H of key is the final hash function. So this we will use whenever collision occurs. If there is no collision, now generally to insert an element, the general hash function used is key modulus hash table size only. If collision occurs like above situation, then by using linear probing you can resolve by applying this formula. This is linear probing. Now in quadratic probing, how the collisions are resolved? H of k equal to, this is general hash function like key modulus hash table size plus I square modulus hash table size. This is quadratic probing hash function whenever collision occurs. Now the next one is double hashing. Why the name here double? Double hashing, here it is, second hash function is used to resolve collisions. That's why it is called as double hashing. So h of k equal to small h of k plus I into second hash function h2 of k, there's a whole thing modulus hash table size. So second hash function is represented with hash 2 of key. Okay, so now what is that hash 2 of key? And I equal to 1, 2, 3, 4 and so on. Now what is this h2 of keys? What is the second hash function? Second hash function used is, you have to consider a prime number. So prime minus which key you want to insert, that key modulus this prime number. What is this prime number? The prime number is less than hash table size, which is less and near to the original hash table size. What does it mean? So suppose hash table size is 10. Then the prime is a prime number which is less than 10. That means 7 is the prime value we will consider. So this is double hashing. Like that. So open addressing is divided into three techniques: linear probing, quadratic probing, double hashing. Okay. So rehashing. In rehashing, that means if table is more than half full, that means greater than 50% is full, then there is a less chance to get an empty cell for the key. So that's why we will rehash the elements. That's why here it is called as rehashing. In this, a new hash table size is considered. So what is a new hash table size? New hash table size is double the given hash table size and consider the next prime number. What does it mean? For example, hash table size is 10. Double it, then 20. So after 20, what is the immediate prime number? 23. So what is the new hash table size we have to consider? 23. So based on this hash table size, again insert all the elements into this new hash table. That's why here it is called as rehashing. Now extendable hashing means if large data is there, so and the elements are stored in the manner of or based on the bits, so it is called as extendable hashing. So now this separate chaining is also called as open hashing. Separate chaining is also called as open hashing. So this open addressing is also called as closed hashing. Closed hashing. So now these are the collision resolution techniques used in the hash function. Each one is having its own advantages and disadvantages. You know, linked list disadvantage, so it occupies more memory. So is the disadvantage in separate chaining. In open addressing, linear probing, quadratic probing, double hashing is there now. So in linear probing, the disadvantage is primary clustering. In quadratic probing, the disadvantage is secondary clustering. Why I am writing all this in a single page? It is easy to understand. So summarizing, if we have seen, it is easy to remember also. So the disadvantage here, it is secondary clustering. Okay, now third one is second hash function calculation will take more time. Okay, rehashing. So whenever the table size is greater than 50% na, then we are using this rehashing, but the hash table size is increasing. And for rehashing the elements will take time. So, and that is a disadvantage of rehashing. Next, extendable hashing. So extendable hashing is whenever, generally it is mostly used if the data is very large in size. So if data, nowadays data is increasing, so the data is increasing and the data will store in the table format, and which has to take less time. So that's why here this extendable hashing is used. Okay, so these are the collision resolution techniques. Hope you understand, students. In the next video, we will discuss one by one with examples. So separate chaining, open addressing, rehashing, extendable hashing. So with examples, we will discuss in the next video. Okay, students, if you like the video, please share with your friends and subscribe the channel. Thank you, students. Have a great day. Bye.